So we're going to start by recalling a definition really, that you'd seen previously. And that definition was of a partition. So a partition, P, of a non-empty set S is a collection of pairwise disjoint non-empty subsets of S whose union is S. So in case you don't remember, pairwise disjoint means if I take any two of these subsets and find the intersection would be the empty set. So let's revisit an earlier example from our previous video. Visit our earlier example. So if you remember, we had our set A, which was A, B, and C, and we found there was a relation R. I'm not going to write it down here, but we found the distinct equivalence classes. We had the equivalence class A or B, they were the same, and then the equivalence class of C. And if we look at the set of these equivalence classes, so the set containing the equivalence class AB and the set C, we can see that this is a partition of A. Why is this a partition of A? If I take any two of these sets, there's only two of them for me to take, but if I take them and intersect them, I get the empty set. And if I take the union, I get the set A. So I meet the two conditions of being a partition. The first one tells me that the sets are pairwise disjoint. And then I meet the second condition that the union of my sets disjoint. Okay. So you might wonder, does this always happen? Is this something special that's happening? Or is it always the case that my equivalence classes, my distinct equivalence classes, form a partition of my set? And the answer is that this always happens, and that's this theorem 9.11. So theorem 9.11 says let R be an equivalence relation defined on a non-empty set A, then the distinct equivalence classes resulting from R is a partition of D. So essentially what your equivalence class is doing, it's taking your set and it's partitioning it into subsets. So if you think about our earlier example, right, our set A had the elements A, B, and C in it, And what it did is it broke up my set into two subsets. The first one containing the set AB, and the second one containing the set C. So I'm breaking up my set A into two pieces, essentially. And as long as you have an equivalence relation, this is what always happens. Your equivalence classes break up your set into a partition.